We are here to talk about, are we ready
Just
for a
under our photos.
are we ready for a quantum future? And today is all about emerging technologies and talking about innovations. And this is really one that's on a lot of people's minds right now, because quantum-powered technologies, as I'm sure we'll come to discuss, are no longer just the reserve of science fiction. They are becoming talked about in rooms like this, in conferences around the world, and as we may talk about in boardrooms as well, and with industry leaders. So we know that quantum technologies have the potential to transform everything. So what we're going to talk about today in this conversation is the potential impact, the implications of quantum transformation, and think about, I'm going to ask the panel, are we ready? Are we ready for that future? And if we're not ready, perhaps who is ready for that future? So we're going to get a bit of a sense of where we are right now, what the future could look like and how we get it right for not just industry, but for society and for everybody everywhere. But then also, how do we move forward and what could moving forward look like? And I'm hoping we may have some time for questions, but we'll see how we go. Let's kick us off. I'm just hoping that the time on my clock might start, so I know how long, because we could go, oh, thank you, we could take up the whole evening, but I'm sure you might have homes to go to. But let's kick off the conversation first. I'm going to ask my panel to introduce themselves. We have a really amazing panel, but enough from me, let's hear from them. Philip, perhaps could you just introduce yourself to everybody, and thanks for being here. It's really great to have you here.
Very happy to. So I'm Philip Ernst. I'm with McKinsey. I'm focusing on tech-enabled innovation, and within that, specifically on quantum technologies. Brilliant. And we put a lot of effort in that research, and I'm very happy to share some thoughts about it today.
Right. Carolyn, great to have you with us. Just tell everybody who you are.
At CogX. I'm Carolyn Holter. I'm at the University of Oxford. I'm a researcher in the Responsible Technology Institute. And we look at kind of responsible applications in a variety of domains. Quantum is one of them. We also look at autonomous vehicles, but it's all about how new technologies can impact society. So looking forward to talking about that today.
Oh, great to have you with us. Markus, welcome.
Thank you. So I'm the founder and CEO of Terra Quantum, one of the larger quantum tech companies globally. And how did I get there? So I'm a quantum physicist actually by education, studied quantum field theory at CERN in Geneva, but then left the space for more than 20 years doing investment banking, corporate finance, private equity. And 4 years ago, actually thought it's time to combine those two things, my passion for quantum and the corporate finance background, to commercialize quantum.
Brilliant. Oh, right place, right time, perhaps. We'll talk about that as well. And Stephen, really great to have you with us. Please introduce yourself.
My name's Stephen Nundy. I'm a partner at a venture capital fund called Lakestar. I look after the UK office. We're a pan-European venture capitalist. We invest in early and up to growth stage. My background, though, is I'm an enterprise engineer by trade. I spent 20 years working at Goldman Sachs building technology, both here and in Asia. And so I came across quantum for the first time actually when I was working at Goldman, and so I'm now in a fortunate position as an investor to be able to follow my dreams, or the hopes and dreams I think many of us have, and helping kind of build that next generation of quantum software houses.
Yeah, it really does feel like we've been talking about quantum at TechUK for a few years now, but it really does feel like we're at the kind of cusp of something really big, and we're going to touch on what that thing might be in terms of how we move forward. But before we kind of look to the future, I always like to think about where we are right now, and whether, where quantum is right now and quantum technologies. And of course, there's lots of different quantum technologies, but I'm sure we might touch on that. So when we think about preparing for the future, we actually need to think about where we are with quantum. And there are a number of early forms of quantum technologies that are available now. So I want to kind of start with exploring perhaps, how quantum's being used today, and how can this help us understand what the future may look like? I mean, Markus, can I perhaps start with you, given Terra Quantum's already working in this field? What are you seeing?
Sure. I mean, in general, of course, we have a disruptive technology, right? I mean, the speed up of the compute power of a quantum computer will be exponentially, right? So that explains it all. So it will disrupt on the long term almost every industry which has to do with optimization, simulation, machine learning. Where we are today, I think we have, I call it a broken compute stack, right? We have the classical high-performance computing architecture, which comes to certain limits when it comes to optimization, simulation, and these things. And then we have the quantum side differentiated or divided in the software piece, quantum software, and the hardware piece. And we all know potentially that the native quantum chips, they do not yet scale, right? There's a lot of R&D, great R&D going on from academia and the quantum techs and the big corporates. Everybody is thrilled on that, but it still takes a few years' time until those native QPUs are powerful enough so that you can do really meaningful things with it. But the quantum software side, the quantum algorithms, they can be developed right now, actually. And what we especially do as Terra Quantum, that's our USP, we kind of hybridize the approach. We fix the broken compute stack and take the best of breed approach, meaning we use the quantum algorithms and run it as long as we don't have more powerful native QPUs, we run it on virtualized qubits on classical HPC compute architecture. And by that approach, we can already unleash some of the potential of quantum today. And we actually have a lot of clients who use quantum today and achieve big savings today already with it. So the short answer is quantum is already more advanced in its application than a lot of people think.
So if that's the case then, and quantum is here, how do we then explain? How do we get business leaders to understand what it could mean for them? How do we get them to understand what it could mean for them right now as well? Stephen, I don't know if you've got a view on this. Do we need to help business leaders kind of understand? Do they think quantum? No, it's not for us. How do we get them to think about it?
I think you've got business leaders under a lot of pressure to run the here and now.
Yeah.
We're all either re-platforming or we're looking to use the latest and greatest to give us efficiencies in our day-to-day.
Yeah.
And I think what Markus and the rest of the quantum ecosystem are saying is you can start experimenting today in a meaningful way. And so I think that's where we need to start having this dialogue across the corporate world and elsewhere to say that you have to start experimenting now. These technologies will take a long time to fully come up to speed. You need to start understanding what this means to your business if in 5 years' time there is a solution that could revolutionize the way you think about a certain aspect of your business and start preparing the change of how you pivot from a business that does it this way to a business that does it this way, because these things take time. If there's one thing I learned working in a large organization, it's time it just gets eaten away. Unless you start early and you prepare early, you're going to miss the boat.
Yeah, and Philip, I'll come to you in a minute, but Carolyn, you wanted to come in. Is it, what do businesses need to think about then?
It's just that, we think that the quantum computing community absolutely needs to be starting to have these conversations with business. There are some highly likely first use cases for quantum, fintech, pharma, materials, and the community really needs to be having these conversations with businesses, sort of making them aware of what's coming. I'm sure Markus knows the ecosystem very well as well. So
yeah, and we'll come on to how we do support the ecosystem. But Philip, from your point of view, helping business leaders to understand this, how, in your view, how do we need to do that? And talking to Stephen, how do we start that dialogue? Is it looking at case studies? Is it looking at what outcomes quantum technologies could mean? Is that how we need to approach the conversation?
So the first thing is that there are actually players who are early movers who actually work with the industry already, right? Who are working into the first use cases in order to establish advantages, right? And some competitive advantages in time. I think the second thing is when we talk to business leaders around this is often around the strategic aspect. Does quantum actually disrupt my industry? What are use cases around this that have significant value for us? And when is also the time when we have to start actually investing into this and get going? And this is obviously with a couple of industries like pharma, where it's early on, around chemistry in general, but also automotive has already put in quite some work already, and this is starting up. But also, I think it's not yet there where it should actually be, given the potential impact it can have.
Yeah. So timing is everything, right? And knowing when to invest is everything. And I suppose, Stephen, that's part of that conversation as well, of helping business leaders to understand where we are right now in terms of when's the best time to think about what it means for their business.
Exactly. I think there's going to be some business changes that may take years to implement off the back of this. And so you could wait around until the hardware is mature, but I think to Markus's point, to the extent that you're already experimenting, you may not see that step change speed up or outcome for a number of years, but you can start modeling this out, and you can start getting confidence that when the change is there and the hardware is there, that you're ready to embrace it. Because if you don't, and another business leader has taken a more progressive view, you're going to be behind the 8 ball, right? And we've seen this a number of times where these kind of sliding door moments happen, and before you know it, you are playing catch up.
Yeah. So Markus, I'd love to bring you in on this point, and please do give your reflections, but also I want to ask you around, we're talking about business users of quantum, right? But as Carolyn kind of set us on that track around the ecosystem itself, the quantum industry itself is really thriving and growing here in the UK, but around the world. So what thinking about them as the enablers of our quantum future, what do we need to do to help them scale and grow? But please, you wanted to come in as well.
Well, that's a very, very exciting question, actually, an interesting one, but probably more to Stephen's point. I mean, how do you get started with quantum as a corporate when at an early stage of the industry, right? That's why we established the approach of quantum as a service, because to lower the entrance barriers for corporates so that they don't have to have their own quantum talent, because scarcity of talent is a big one. And secondly, that they don't have to invest in hardware at this early stage. So therefore, we bring everything kind of and help them to migrate use cases which they currently tackle in a classical way into the quantum room, and then deploy it via the cloud on our own hybrid quantum machine, right? And by that, we can achieve early advantages already today. Just very briefly, one example out of the financial services industry, there is within investment banking a mission-critical optimization algorithm called the collateral portfolio optimization. It's a couple of 100 billion sitting on the balance sheets of the investment banks. So if you can just improve the performance of that by a few bips, it's huge, right? And what we did actually was, based on the data of a European investment bank with a 400 billion collateral portfolio, did exactly that approach, and by running it on our machine, we could improve the performance by 6 bips, and that translates in that special situation into 240 million euro annual recurring cost savings. And that is something we can achieve today, right? So therefore, we say quantum is now. But now, of course, the hardware research goes on, and what do the quantum ecosystem, what do we need, so to say, right? Because we have the large corporates, and then we have that kind of flourishing, growing quantum tech ecosystem. And I'm a strong ambassador to support those startups and scale-ups heavily, because I think this is also the driver for future economic growth, right? If you look into who has disrupted the automotive industry, it was not the incumbents, it was a startup, right? And I do see the same thing partly also happening in the quantum industry, and therefore I think it's a very wise decision of every region actually to strongly support quantum tech startup scale-ups. And what do they need? They need more talent. We need, thousands of quantum physicists, so education should increase, and of course we have to have a flourishing venture capital industry. So we need capital to drive those product developments.
Pflitsch, just wonder, from your view, is that what we need, or is there something else that you think the industry needs to thrive?
So first, building on that, we've actually done an analysis looking at quantum talent. And yes, it's very clear that over the next 5 to 10 years, there's actually going to be quite a bit of scarcity, given the ramp up you will need to do on the type of use cases once the industry really realizes the value behind it. So that's number one. I think the second point is also very much in line, and specifically if you look at Europe in comparison to the US, it's still the case that specifically scale-up capital is much more geared to there. And if you're looking at the investments in terms of startups within this, then it's definitely like almost 80% in the US. And we are actually publishing our latest edition of the Quantum Monitor tomorrow, which gives an insight on how the capital flows, what's happening there exactly.
So we should end the panel now and then come back tomorrow. Is that what we need to? But no, we'll be looking forward to seeing those results, and it's really important to see this industry grow and evolve as well. So huge benefits, huge potential, but just thinking about how we move forward, and Carolyn, how we get this right? There's huge benefits, as Markus outlined, huge economic potential for lots of different industries and sectors. But how do we get this right for society? How do we get this right for people? How do we get this right for all of us? Because this is, as I think all the panelists have said, this will transform, this will have an impact on not just industries, but all of our lives, right? So how do we get this right from, and this is very close to my heart, from a kind of ethical and responsible tech point of view?
Well, actually, some of these points around the investment that's needed and the people that are needed are also part of the kind of the building this responsible technology.
Yeah.
Because when you look at finance, for example, evergreen funds that are now able to just kind of trickle in money over the longer term, rather than, say, giving big tranches to startup companies in one go. That means that companies can make more progress over the longer term without so much hype. And we see hype as a real challenge because it can lead to over-promising, and then you either get a quantum winter, as we've seen in numerous cycles of AI winters, or you kind of, the over-promising leads to people perhaps pushing the technology further than they should, or not going about things in a responsible way because they feel that pressure to deliver.
Yeah.
And the capacity question is really interesting as well. We were talking earlier about the conversations that the quantum computing ecosystem needs to be having with industry. When you start having these broader conversations, especially as the industry expands, you don't just need quantum physicists, you need all kinds of people. And so the more awareness there is, the more you have these conversations, the more people can be drawn into the industry.
Yeah.
And like a lot of the tech industry, it skews perhaps in a particular direction. And we need more, we need to see different people coming into the industry. We need more diversity, as we do in so much of the tech world.
Yeah. Philip, did you want to come in there?
Yes, I think let me take that from a slightly different angle, because I think what we should not underestimate is also what quantum can actually change to the positive. We've looked intensively at sustainability use cases and really identifying what would be elements where you can accelerate tech roadmaps in important technologies, for example, in the hydrogen economy, around direct air capture, solar cells, and really pull that up by decades, right? And if you really do this, you can come to a point where you save something like 7 gigatons of CO2 per annum, which is basically something like 20% of today's emissions, right? This is just the potential, but just laying it out there, right? There's also responsibility in actually pushing this and making it happen, because this can be one of the technology aspects that can really help with climate change.
So an ethical responsibility to pursue quantum technologies and what they could mean. But Carolyn's point about not going too fast. And, yeah, Stephen, I was going to bring you in about, because this is so key to public trust and public awareness is key to this, right?
It's interesting. We can talk about, and obviously with my venture capital hat on, right, sources of scale-up funding in Europe is a challenge, right?
Yeah.
And that's why funds like us exist, and we're trying to unlock capital from other pools to allow us to invest in deep tech startups and startups in general in Europe. I think that's critically important. And the US has a massive strategic or structural advantage in the fact that it can tap into pension fund money to fund startups. And the irony is right now, a lot of European startups are actually benefiting pensioners in Canada and the US more so than pensioners here in the UK. And that's we can have a whole session talking about that.
The whole other panel.
But I think the piece that really highlights, though, is we need European companies to emerge. I think to the ethical point, we can talk about the use cases of quantum being very important, but let's look into the future where we have a world where the use cases are working and they're running on technology that's owned by a non-European startup. We need to learn a little bit from what's happened over the last 20 years with payment rails, with Visa, MasterCard, American Express, with cloud, Azure, GCP, and AWS, right? Where are the European winners in that category? There are none, right? And open banking is going to help us on the finance side, but we've failed on the payment rail side. We've now got a brand new compute paradigm that's going to be emerging over the next 10, 20 years. Shame on us as Europeans if we don't have these great opportunities, these great use cases run on European software and European hardware. Because if we don't, then guess what position in the queue we're going to be if the hardware and software sits in another continent when it comes to being in the queue for this new wave of compute. I remember being in CogX a few years ago before COVID, and there was a quantum conversation then, and people were talking about how much data has been harvested that's just waiting to be cracked by a quantum computer, right? You can't crack some of these secure codes today, but you can in the future. And so people are just stealing data today to be cracked at a later date. So he who gets there, or he or she who gets there first, unleashes a whole series of other ramifications. And so again, as Europe, we need to coalesce as investors, as entrepreneurs, as research scientists to make sure that we don't just run to the water's edge, kind of drip a little bit of money into quantum and then run back again. And at the meantime, you've got nation states in Asia and the powerhouse in the US throwing big amounts of money in, and they're not afraid to fail. I think one of the challenges as Europeans, we talk about the US innovates, Asia replicates, Europe regulates, right? We need to get out of that mindset of just being super cautious, nice guys, to being a bit bolder.
Yeah. Carolyn, I saw you nodding there, because part of this is also not just helping the community grow, but then it's retaining that community, right? And supporting it to grow here.
Exactly, and particularly in the UK, we haven't been very good at keeping industries here, making London particularly an attractive place for them to list and to grow. And yeah, we do need to think about how we address this, but I think we also need to be thinking about this in a global sense. The quantum computing community is a very small one at the moment, and everybody knows everybody else, and there is an opportunity there to kind of keep it global. Let's not get too nation-statey about it. There's still so much work to be done. Let's keep collaborating as long as we can. And I think access is a key as well. Yeah. There are countries in the global south. Is this going to be a northern hemisphere technology? We need to have those conversations too.
Yeah, absolutely. Markus, did you want to go in there?
Yeah, no, I totally agree what you say. So we have to collaborate. It must be an active ecosystem where everybody contributes to make it happen. But nevertheless, we have to look as Europe, I would say. I mean, our company is based in Europe, continental Europe, and therefore we are quite proud that we recently finalized one of the largest global quantum tech fundraisers, not sitting in the Silicon Valley, but in Europe. I think that's very, very important because, every region must have not only, I would say, access to a quantum computer, but you have to own it, right? Because in these days where you see suddenly disruption in the value chain, what happens if you can only run on a quantum computer, but you don't own it, right? So I think we have to think carefully about kind of how do we manage kind of ownership and access to quantum computing. Also, because it's geopolitical, it's important for the economic prosperity of a region, and then also because if you don't, you become a third world region, so to say, and it creates huge inequalities. And I think we have to balance out these inequalities which will arise from access to quantum computing, yes or no?
Yeah, that's a really key point about the inequalities and what it could, amplify, and how do we address that? And I'm thinking about it from a from a governance point of view as well, not just, how do we reckon? Well, we need to recognize, right, as we started to with the AI conversation around, let's identify some of the inequalities, let's identify some of the really tough questions that we may need to think about. Before we find solutions, we need to identify them first. Do you think we need to do that around inequalities and governance, and then work, through those issues? I don't know if anybody wants to come in on that.
I mean, we are actually already, if I may start, we are already contributing as Terra Quantum in a kind of open think tank called GESTA in Geneva. That's the Geneva Science and Diplomacy Anticipator, where we actually discuss already these questions in terms of access, how do we avoid inequalities, how do we apply quantum for good, like climate. I think it's very necessary to start now to think about that, and not in terms of regulation that it stops kind of the economic stimulus, but to think already kind of in an advanced way, how do we make it work, how do we manage kind of accessibility and stuff like this.
No, completely. I think, we need to start having these conversations. But again, thinking about where do we want to get to? Let's not just think about what's the next step in the technology. Let's think about the kind of world that we want quantum computing to enable, and then figure out how we get there. And as I completely agree that it's far too early to think about regulation per se, but governance happens at many, many levels. So you've got legislation, regulation, you have industry standards, you have kind of research ethics in universities. All of these things are governance. And again, having conversations with business leaders, with the public, that is a kind of governance because it provides transparency.
And we can learn from conversations we've had around other technologies. Stephen, you were mentioning some of the technologies that we've seen evolve over a number of years, right? We've had this conversation before, so we can. Obviously, there must be lessons that we can learn from our experiences in the past.
I think we can. As I said, I think it comes back to the point of collaboration. I think we just need to be progressive in our thinking here as a European startup scene. We need to liaise and work with folks in the US and folks in Asia, undoubtedly. I don't think, when I talk about Europe as a geography, not the 27 nations that we don't happen to be part of anymore. And I think that's just important, that we don't become an island state here as well, right? So I look at this from both sides. We've got to make sure that the British are working with the French, working with the Finnish, working with the Germans, that we don't start really kind of closing down shop and flag waving about we've got a quantum computer in this city or that city and you haven't got one. We need to collaborate.
But I think at least in terms of the importance versus kind of the last digital revolution, which Europe had missed, at least now governments are spending much more and are much more active already. So within Europe, also what you see within China, the spend is actually much higher from the government side than it is in the US right now. So at least on that front, governments have understood this and are pushing also strongly in Europe.
Yeah, so it's interesting because we always see it, TechUK as public procurement and public sector investment in technology is going to be a real catalyst. So I'm thinking about, who's not part of this conversation that we need to bring in. Maybe we need to be starting thinking about what the quantum technologies could mean to public service delivery. But I'd be interested in the panel's views on, okay, who's not in this conversation? Who's not in this room, but who's not in the room that we need to have in this conversation? I don't know, Markus, if you want to keep this on.
Well, my opinion actually is we have to have. Yes, we need this kind of public funding, and there are public funding programs, but one should have a business model which is commercial in itself, because I think there is one danger. A lot of these quantum techs are spin-outs from universities, so they come from academic roots, and they are used to that kind of public funding scenery, whereas I think, no, we should have a commercial business model, and therefore those early use cases which show a quantum benefit are so important, to increase the level of interest of large corporates, because that's what I think we need. We have to have very kind of open large corporates who want to deploy quantum at an early stage, who want to experiment to get it kick-started, right? There's no better thing like this. And if I I mean, we are doing, business development on a global scale, and I experienced that some of the large US corporates are more open to just get started with something, whereas some of the European companies are a little bit more hesitant to start experimenting. So I think we need a stimulus from the industry actually to use quantum today. So this is not a thing where you should just get started and be kind of intellectually informed. This is about getting really started with some mission critical use cases which you explore what quantum will be able to do for
I think one of the things that I bang on about sometimes here in the UK is I think the R&D tax credit that the HMRC have put in place has been used to an amazing extent.
Yeah.
So the question I'd pose to the audience and to policymakers is, how can we use those types of incentives to ensure that we are promoting the right type of R&D in this country and across Europe? Should there be a higher bar to getting, if you're a corporate, to get those R&D tax credits, because you have to show you're truly innovating and using the new technologies that are out there? To me, it feels that the bar is relatively low for corporate to get those R&D tax credits. So can we change the bar, or can we add an incentive structure to unlock the innovation budgets in some of these large companies? Because otherwise, I think we need that encouragement as well. And maybe that is something the government can help with, or policymakers can help with.
And I think, listening to Markus, I think that's really the risk of missing the boat again, right? If now the application starts and is driven more from the US than here, that's also where obviously the talent will go, right? Because it will coalesce around these use cases where something's really done, where you can really see value. And if I have the choice, where do you go, right? Do you go to a group where you do some basic research, which is nice, or do you go to the place where you can have like the first real impact and make it big?
Yeah.
And I think this is the point where also now the corporates start to get aware, but it's really where they have to take also some of the risk which is involved in this, because it's a multi-year journey. It is coming with the typical technological uncertainty, but the size of the prize in this case is so large that you actually have to take some risks.
Yeah.
And here I would like to probably to put a positive note on these things. I mean, this is a totally disruptive technology, and it's not a question of if it works, it's just a question of when is it how powerful, right? So we could be really excited to have a technology at hand, which we all experience in the next years, which is doing so amazing things, on almost every industry. I mean, optimization, simulation, machine learning, all these things will be completely disrupted by these machines. So it's actually a great new chance to tackle challenges of the world with that new technology. So there should be a positive excitement actually all around, to get used to it and make use of it.
Yeah, no, it's definitely something we've been driving at TechUK as well, and we've just published a report very recently on quantum commercialization. And okay, what are the pieces of the puzzle? How do we get this right? And what does getting this right look like as well? So really, really important. It's Carolyn, absolutely. I mean, I am very excited about our quantum future, as I'm sure we all are. But back to that question of who's not in the room, who's not part of this discussion. I remember when we had our very first, I think, digital ethics summit many, many years ago at TechUK, and one of the panelists said, I'm interested in who's not in the room. It's great to see so many people. We had a packed room. It's like, but who's not here? Who needs to be here? And we were talking about, the philosophers, the ethicists, the people in the room. Yeah. So who needs to be in the room so that we get this right from a societal and an ethical and responsible way? Not just you, obviously, you're brilliant.
The short answer is everybody. This needs to be a societal conversation. And, these are where the rubber hits the road, where you've got really kind of real world challenges. You need really interdisciplinary work for that.
Yeah.
So we do need economists, we need lawyers, we need social scientists, we need behavioralists, as well as engineers, quantum physicists, and all of the technical disciplines. And we need to be having those conversations. And they're often very difficult conversations to have because people are coming from very different starting points. And you get challenges at the boundaries of disciplines, like people use the same word for a different concept or a different word for the same concept. And it takes time to really get these disciplines meshed. But in order to look at real world challenges and things like sustainability, things like sustainable development goals, these need a kind of a broad range of approaches. And I think quantum computing and the way it's going to impact society is another of those challenges. Yeah. And so we need to hear from as many people as possible. And this is why I keep saying we need to be having the conversation. There was a public dialogue a few years ago, but we need to be having that in a much bigger, much more systemic way. Yeah. And not just with, civil society. We need to be talking to policymakers. We need to be talking across industry. So even if you're not in an industry that is going to be necessarily directly in the first wave affected by quantum computing, you need to understand that it's out there, that other industries that you may deal with, that you may have those interfaces with, are going to be affected.
I am optimistic that we're at least having the conversation that we need to have the conversation this early on, as this technology is still evolving, right? At least we're recognizing we need to have that conversation, which to me feels different. I don't know if it feels different to you.
No, I completely agree. I'm actually quite optimistic. I think it's partly because quantum is so difficult and so expensive, because it's still quite a small community. Yeah. There is this sense of care, of let's get it right, let's be careful of the future. And we've all seen object lessons from tech that has gone wrong in the last few decades. Those lessons are out there. And I think, there is a willingness to learn from that and a real desire to try and to get this right and to shape this in a way that does benefit society.
And Stephen, we need to balance that, be careful, but also move, you talked about culture and getting the culture right, move in a way that we move this technology forward and we don't miss that opportunity, as Philip's saying. So it's a balance, right?
Yeah, I remember my mum once said to me, I don't believe in the internet. And I chuckled to her as I was using Skyscanner to get a cheap flight. And, we just can't have our head in the sands on this one. It's a complex topic, right? Yeah. It's something that can scare most people off. Yeah. And it could be something that's just, it's in the future. But to Markus's point, and to the point of the panel has mentioned, it's like there is applications today. And so if you are the CEO or you're the CTO or you're head of innovation, then you should have a pocket looking at this and investing the time and the talent into it, because you become aware and then you understand, what your risk-reward profile looks like in your organization. But just ignore it, that's shameful.
And there is this element where you can't get it wrong on the quantum threat, right? I mean, you spoke briefly about the security issue, right? I mean, quantum computing will, sooner or later hack every classically encrypted code. So an organization has to be made quantum safe today already, because you have that concept of harvesting the data, the classically encrypted data now, and deciphering them later on a quantum machine. So there is no way to just wait and see. We have to make our organizations quantum safe today, prepare for the quantum hack, because we do not know when the hardware will be there in the various regions of the world. Once the hardware is there, which is powerful enough, you wake up and you are hacked. So therefore, that is an urgent task all actually organizations who deal with confidential data have to tackle.
I think this is one of the aspects where I think which creates a lot of fear, because people don't understand it. But out there are actually already technologies around post-quantum cryptography, right? Which you can tackle this, with which you can actually prepare. Problem is obviously kind of the delay in this. So if you have a car now, that's obviously going to be on the street for the next 15 years. It's probably possible to crack that at some point in time. And while I believe this is an important aspect, I think it often derails the conversation from the really positive elements that this thing can bring. In terms of applying it to the right aspects. And I'm bringing up the climate technology again. And this is you could bring up medicine, drug discovery. Right, so this is just huge and can be huge for humanity, and it would be a shame if kind of technology, which can always be used also for wrong, if you make that headline so big that you are losing the opportunities on the other side and trying to regulate this to death before you already start.
the back to balance again, and how do you get the balanced conversation and narrative right? Stephen, sorry, did you want to?
No, I was going to say, I think it's bringing it to use cases that we all understand. Not all of us will understand how this helps genomics or how this helps climate, right? But the way I was explaining to my kid the other day was he always complains that Deliveroo takes ages to deliver, right? And I said to him, if you think about the maths that goes into route optimization of getting food from 3 different restaurants to 3 different people in our area, what the sequencing should be for the driver to pick that up, what route that driver should take, how that will change depending if they're picking up a curry versus chips with a burger versus sushi, how that changes different times of the day, different days of the week, different weather conditions, whether there's roadworks, whether the low traffic neighborhood is live or not live, right? Just that, to be able to do that every second of every day, a regular computer cannot do that, which is why delivery drivers challenged to do more than 3 drops an hour, which is why some of these delivery models aren't as efficient as they could be. So we can talk about all this amazing things that are going to be done for good, but if you want to start boiling this down to things we all understand, just think about how you get your food delivered and how much you're paying for that and how inefficient it is. And computers, quantum computers, can solve at that level all the way up to climate change, battery technologies, finding new molecules.
And it becomes really very soon very complex. That is a very good example. We are working for a retailer actually who has a huge fleet of trucks, right? And empty miles, if a truck drives with empty miles, that's not a good thing, right? Also not for climate. And what we do actually is a quantum-powered route planning where we could bring substantially down, again, already today with our quantum algorithm, substantially down the amount of empty miles driven, right? So that's of course a good thing. And we just published work we did with Volkswagen on the optimization of the workflow scheduling system, which is really kind of getting into the area of manufacturing, bringing it at scale, right? So again, there are a lot of use cases which are very practical where we can work on today already.
I should say for balance, other food delivery services are available.
Absolutely, they are. As is your feet.
As is your feet, indeed. Or your bicycle. We are very quickly running out of time, so I'm just going to bring this, I'm sure you'll all agree, this fascinating panel that we could go on for some time to a close. I want to bring us back to the title of the session now, Are We Ready for a Quantum Future? And rather than go down the panel and go yes or no, because that's terrible, I wondered if I could ask each of you, all right, we've covered a lot of ground today, right? And this has been brilliant conversation, but what is the one thing, the important thing we need to get right, perhaps now, to make sure that we are ready for that future going forward? Perhaps, Philip, let's start with you, and then I'll work down.
I think it's really corporates starting to think about what it does mean for them in order to trigger everything that comes down the line.
Carolyn?
I really want to see just a kind of rising public awareness and knowing about these different use cases, as well as things like the security implications. But also, as we commercialize, let's not be too focused on dollar signs, and let's take some of these responsible approaches with us.
Markus?
I would rather really say that the key lesson is quantum is now. There is no quantum winter. There is no wait and see and just get intellectually prepared. Quantum is now. There's a lot of useful stuff we can already get started with. Let's do it.
Yeah, Stephen, the last word.
We talk a lot about the war for talent and avoiding repeating what some of my colleagues have said. I think universities and schools talking about these game-changing technologies now, because in 10 years' time, my son and daughter are going to be in the workforce, and if they don't know about this because the schools and universities aren't training people to think about these things in a different way, then it's going to be for nothing, and we're going to have another talent issue in 20 years' time, 10 years' time.
Yeah, it's amazing. I remember somebody mentioned before in another panel the BBC Micro. That was my first ever computer. I'm remembering how to play games and program games, and then probably that's where it all started. Then if I think about school, I was learning how to use Excel, and to think that kids may be taught what quantum computing is just blows my mind. But look, I'm sure you'll agree with me that that's been a fascinating panel, but also I think if the CogX gods are listening, definitely a topic we need to come back to and we need to keep talking about, because it's going to be increasingly part of the, and it is already, but increasingly part of the tech conversation, not just here in the UK, not just here in Europe, but around the world. And we need to make sure that we are all ready for our quantum future, to say Carolyn's point. So can you please thank the panel in the normal way? Philip, Stephen, Markus, Carolyn, thank you so much.